Welcome to this Pawsey Supercomputing Training module on Bash Shell Basics. So this is just a refresher module, and it's a prerequisite to our Supercomputing User Training series. So you can find these very materials that I'm showing right now on our Pawsey GitHub repository. We will hand you out the PDF with links to access both the PDF itself and the web page version. This is the outline of what I'm gonna talk about and show you in this session. There will be a few definitions just to start with, to define some jargon, and then it will be an all hands-on session covering a number of topics. So handling directories and files, using environment variables, editing and visualizing files, and manipulating outputs and text files, and just a few extra commands and tricks. So this is just all of the definitions and concepts that I'm going to present to you today before moving to the hands-on. So what's a command line interface? So it's a type of interface to use and engage with a computer that requires the user to type textual commands and read their textual outputs by means of a prompt. This is what command line refers to. And note that some commands may also need optional or mandatory arguments. What's a shell? So a shell, it's a program with a prompt that provides a command line interface as defined above. The shell also provides an interpreter which is able to understand and execute the commands you type and show the output. There are different implementations of a shell that use different shell languages. And Bash is one of the most popular shell languages in the world. That's the one that we're going to cover in this session. A shell script is just a text file containing a sequence of shell commands. It can be executed using a shell, and it's quite useful to increase reproducibility of a workflow. We're not going to show examples of writing shell scripts today, but any command that I'm going to type is also a legal command inside a shell script. So what are the main advantages of using a shell? Productivity, and that's because with a few keystrokes by typing commands, you can achieve quite a lot of actions compared to programs that use a graphical interface. So the command line interface is more productive. Task automation, thanks to commands that help automate actions. Reproducibility, especially when using a shell script, so the ability to rerun the very same sequence of commands over and over. A text editor is a program used to open and edit textual files. Some text editors are designed for use within a command line interface, and examples of this type are Nano, VI, and Emacs. Today we're going to use a bit of Nano. Note that in all the examples in this reference sheet, the commands are identified by lines starting with $, which is quite a common convention, which represents the prompt. So the $, never has to be typed if you try and run the examples by yourself. The other lines will represent the common outputs, and in Bash, comment lines are denoted with a hash symbol. So just to give you an idea, let's say $, is a command. The command denotes, the hash denotes a comment, and here, no $, no comment, this is an output. So here in the materials now there is the transcript of all of the commands I'm gonna run with you, but I'm now gonna move to a terminal window with a shell session open, and I'm gonna start with the hands-on. So the first topic I'm gonna cover is handling directories. And so first thing, let's navigate to the home directory. This can be achieved by typing the command cd without arguments, or also cd space tilde. Tilde is a shortcut also to represent the home directory. And we can verify which directory we're in by using the command pwd, which stands probably for print working directory. And here we go, I'm in /home/my username. Let's create a new directory. We do that with the command make dir. And so bear with me. This was just a leftover. So let's create a directory called training with make dir. Let's enter this directory. Okay. And we are in home username training. We can refer to the current directory with the symbol dot, So if I go cd dot, well, nothing is going to change because I'm referring to the current directory, but it is also useful in other commands that we're going to discover later. And we can refer to the parent directory, so the directory where the current ones stand in, with double dots. So if I do cd dot dot, I'm now back in my home directory. So let's now go back in this training directory that I just created and create some more directories. I can also create more than one at the same time. I can also create a subdirectory by chaining the path names with a slash. So here one more there. Okay, now just a note. So on a bit more of jargon. So paths starting with a slash are so-called absolute paths. So when you define them, they do not depend on your current directory. So for instance, if I go cd and the full path, it doesn't matter where I am. And then cd again, I'm always going to end up in the same place. Whereas relative paths are the ones starting with either a dot or a double dot or just a directory name with no slash. And this, the outcome of the command will depend on where I am right now. So if I go cd dot dot, I'm now in the home. But if I do cd dot dot again, I'm going one directory back to the parent directory of the new directory. And so now I've changed directory. And same if I go cd and my username, this is a relative path, there's no slash. So this depends on where I am right now on the slash home. If I do again, cd my username, I'm going to get an error because that's a relative path. There's no directory called with my username in there. I'm already in it. Okay, so full path and relative path. That's quite handy. Let's now move to handling files. So let me go back to this training directory I just created. I'm going to use the command touch just to create some empty files. Also do it in subdirectories. So the command touch is actually, its main purpose is actually to change the timestamp of a file, so it's a modification time. But it's also handy because if you use touch with a file name that doesn't exist yet, it will just create an empty file with that name. It's not the time actually to use a command to list the content of the current directory, right? It can be quite useful. So if I use ls, I can list the content of the current directory. And you see there are the directories and files I just created. And I can use ls-l to get more details, like the username of the creator of the directories and files, some permissions, and the size. So directories are typically 4 kilobytes in size. And you see this file 1, 2, 3 are all 0 bytes. They created them with touch. They're just empty. They're just a name right now. But they're just handy for these examples that I'm going to show you very soon. So we can make a copy of a file by using the command cp. So we can go file, copy file 1, copy 1. Here we go. There's now a copy file, copy 1 file. If file 1 had the content, the copy 1 file would have the very same content. You can also rename a file by using the command move. It's a bit counterintuitive, but that's what it is. So move copy 1 to, say, another file. And now copy 1 is gone. It's now called another file. And the contents will be preserved. I can remove a file with rm. Oh, typo. Here we go. File 3 is gone. I can remove a directory. Everything. Oh, actually, I've forgotten one bit. So I showed you how to copy and move and rename files. Let's see how we can rename. Sorry, I can make a copy of a directory. So I can go copy / recursive to make a copy of a directory. And so you will see dir one has some content and copy dir one is the very same content because it's an exact copy. I can also move a file to a new directory. And the command is actually the same as for renaming. So it's still move. But now the second argument, instead of being a new file name or something non-existing, I'm now going to use a directory name. And so if I do now ls, another file is gone from here, and it's now inside there too. So that's how you move files around. So copying files into directories, copy duplicating directories. How about removing a directory? So it's remove -r, which stands for recursive. So remove -r, for instance, copied here, and the directory is gone. Now, there are some characters called wildcards that can use to refer to multiple files or directories at once. So there is the question mark wildcard, which just stands for a single, any character, any individual, any value for a single character. See? But so this just substitute the 1 and 2 in these file names. But I can also go ls and then use the asterisk, and the asterisk stands for any values of any number of characters. See, in this case, the result is the same. Let me show you another example. Let's see what we have here. Here we go. If I go ls dir2 a asterisk, the asterisk will match any number of characters. So I will find the file called another file. Okay. This is all for handling directories and files. Let me now move to environment variables. So an environment variable is a key value object. So basically, you define a name, which is the name of the variable, and you assign that name a string of characters, a value. And you achieve that with the equal operator. So let's go, for instance, hello equals word. And then you can visualize the content of a variable with the command echo. And actually, the variable has to be referred to with the dollar symbol. Right? So echo $hello, and you get the word. There is a variant of this equal operator where you also use the command export, and we're going to discover the difference soon. So export by equal moon. And you see that in this current shell, you still get the variable. What's the difference between a simple equal and export equal? Well, if you start a process inside the shell, so a new process can be a program or even just another shell inside the shell, only exported variables will be available. So let me show you with an example. If I run the command bash, I'm just starting a new shell session, which is a child. It's a subshell. It's inside the parent shell. And so here, if I go echo hello, there's nothing. But if I go echo by, there is still the moon. And that's because by was exported and hello was not exported. This is quite handy because some programs need to read variables from the shell environments, and only the exported ones will be available in child programs of a shell. So this is quite an important variation. And note that, so variables are typically lost when you close a shell session. So if I now exit the bash session I just entered here, what I defined there was lost. You want an example of this? So let me open a new one and define a variable city equal Perth. Now let me exit this shell and enter it again. And now if I go city, it's lost because when you exit a shell session, the variables are typically lost. Okay, now let me go back to the parent shell. You can really assign any string of characters to your variables. Often it is handy to use variables to store path values for files or directories. So my dear, well, this, and then you can go my dear, and you can use it for your command. It can be quite handy. There's actually also a useful way to just store in the output of a command inside a variable. Let me show you how. It's the operator $ with round brackets. So this command will store the output of the command pwd inside this variable. And this can be quite useful in some occasions. Finally, note that each shell session, when started, defines a shell environment, so a collection of variables. And some of them are defined by default and can be quite useful. So there is the home variable, that is same as tilde, so it stores the content, the value, the path value of your home directory. There is the user variable with your username. There is the path variable, which is just a collection, a column separated collection of path where the shell looks for executables and programs to be executed. And so this helps basically if you have a shell environment with lots of programs installed, so that's where the shell looks for your programs. Okay, so let's now move to the topic of editing and visualizing text files. So let's do that with the example of the Nano editor. If I type Nano, I enter this text-based program to edit and visualize text files. And let me type something in. Oh, let me do it again. So let me exit the Nano command with Control X, as you see here in the bottom. The hat stands for control. So Control keystroke with X. And save modified buffer, I will go with no. Let me do it again. So if I type Nano and nothing else, I will start with an empty file with no name. But let's suppose I want to create a file called text. And I'm going to go Nano text. And let me type something in. Line 1, fancy line 2, super line 3, extra line 4, and last line 5. Let's suppose this is my text I need to work with. So I can save the file with Control O. File name to write is text. And confirming with return. The file is saved. You see it says wrote 5 lines. I can now exit the Nano program with Control X. And I now have my file called text. There are a few basic shell commands that allow you to just visualize the content of a file without opening a text editor like Nano. So that's all I've shown you about Nano today. You can review the interactions in the transcript. Let me go back now to the shell, and let's see that, for instance, you can use the cat command to visualize the whole content of a text file. If the file is very long, you can use the command less to navigate the contents of a file in chunks. Go less text, you see that a new window, kind of text window opens, and you could use the keystrokes Control F for forward to move to the subsequent chunks of the contents, and Control B for backwards to move back. In this case, we only have one single page, so it's not very effective, but so it's Control F and Control B to move forward and backwards across a long, over a file that is a lot of content. And when you have done with less, you can use the keystroke Q just to quit this window. So this is how we visualize files, the entire contents of a file with the shell commands. There is also a couple of extra handy commands, which are head and tail. So with head, you can visualize the beginning, the first lines of a file. By default, it's 10 lines. Now, because this file is very short, it doesn't make a lot of sense. Let's just go with visualizing one line of the file. So a head -1, one line, and you just get the first line. And same with tail. So tail, we visualize the last lines of a file. By default, it's 10, but let's just visualize the last one. Tail -1 text, and you get the last line. Now let's move to some commands, just a very small selection of commands for manipulating outputs and text files. And some of these are used often just in trainings and examples, but you can also use them in production shell scripts and during your daily use of the interactive use of the shell. They can help automate and speed up your tasks. So the command WC, it's a word count command. It will print a number of lines, words, and characters of a text file. So in this case, 5 lines, 14 words, and 58 characters, including new lines. The command grep is really, really powerful and useful. So grep stands for GNU report. GNU is a collection of lots of Linux and Bash tools. So GNU report will report on the lines of a file that match a given string. So let's go grep super in the text file, it will search for lines containing the word super. Here we go. This can be quite handy. Now let's talk of piping and redirection operators. These are ways to connect together commands and files. So let's start with the piping operator. The piping operator is which has the symbol, this vertical line symbol. The pipe can be used to connect together the output of a command with the input of the following command. Let's see it with an example. So let's go with the echo command and say, hello world from Pawsey. And pipe it to the word count command. And here we go. 1 line, 4 words, 25 characters. So the pipe operates. There are then the redirection operators that operate between files and commands. So the pipe is between commands. The redirection, which we're going to see soon, are between files and commands. So for instance, suppose we want to redirect the output of hello world Pawsey. So of course, the bare output will be just the same sentence. Suppose we want to redirect it to a file. And we use the right arrow operator. This is the one of the redirect operators. So this way, we create a new file called hello, which contains that string. Now, the single right arrow will always overwrite the contents of a file. So if I go hello again, now the file contains only the last command output. We also have a redirection operator to append the content, so not to override the existing one. So let's go with hello, echo, bye-bye from Pawsey. And let's use the double right arrow. This is the redirect append operator. See, this is a file. And now if we do it again with the double right arrow, well, now it's appended. So you preserve the existing previous lines of the file. And finally, there is the input redirect command, which is a left arrow. So suppose you want to word count the content of a file. And so this is how you get it. So you input redirect the content of by to the command word count. So this time word count does not write anything in the by file. Instead, it reads the contents of the by file to tell you that there are 2 lines, 7 words, and 36 characters. And just for your interest, I'm not going to cover this command, but there are other ND manipulation commands such as cut, transform, sort, and also powerful tools to manipulate text such as sed and awk. And you can find more information on these commands in the software carpentries shell training, for which there is a link in the transcript, in the materials for this session, but also just online on the internet. Let me just show you another couple of commands that are quite handy. Where we're actually using them in the main user training for the supercomputer, for which this session is a prerequisite. So one command is hostname, which just prints the server name for the computer where we are currently logged in. I'm currently on Cetonix, the main Pawsey supercomputer, the Quokka computer. The hostname. There is another command which is which tells you the location, the full path of a command, of a program that you're using. So for instance, which grep, remember the grep command we just saw is actually a program which lies inside /user/bin/grep. Not all commands are programs. So if you go which cd, well, so which says there is no CD in any directories in the path where the shell looks for programs. And that's because CD is something else. So you can use the type command to ask the shell to tell you what sort of object the argument is. So if you go type grep, you will get to know that grep is actually a program inside user bin grep. But if you go type CD, well, you discover that CD is a shell built in. So it's not a program, it's not an independent application and binary executable. It's just a functionality of the actual shell that we're using for the interaction. One last command that we're going to use now is tar. So sometimes you just want to pack up together a collection of files into a single archive that is handier to transfer and share with collaborators, or just move around across clusters and storage spaces. So use the tar command for that to create .tar files that are a single file containing many files. And so let's give it a go. Use tar cf, which means create, and a file with file name that follows. So remember that, yeah, you use C for create and F to provide the file name of the new archive. Say, for instance, archive1.tar, that's the file name of the archive we want to create. And then what are we going to put inside this archive1.tar? Let's put all files called file and all directories called dir. We now have an archive1.tar. We can inspect the content with tar tf. And that's what we have. File 1, file 2, and the directory with the contents, all inside this single file. Now, if we want to unpack, untar, expand this archive, so let's do it in a subdirectory of make dir expand, cd expand. Now, suppose we have copied our archive here. We can expand this archive file with tar expand f archive. And what happens when we run this command is that we get back all of our files and directories that were contained inside the archive. See, and we also get to see all of the content with the if you use the wildcard. One last functionality for tar is that sometimes we want to not only collect together files, but also compress them so that they take less size and can be less space. It can be handy if you have to transfer them, but also if you have to store them, they will take less space. To achieve that, you can use a variation of this tar command, which will zip compress the files. So you go tar create zip file called, for instance, archive2. And when you zip compress, you typically use the extension either .tar.gz or tgz, one of the two. This is just conventional. And let's do the same. So let's compress again same files in this zip compressed archive. You can still watch the content with tzf, same files. You could expand with tar xzf, not doing it now. Crucially, if you ever look at how much space they take, so archive 1 takes about 20 kilobytes, and archive 2, which is compressed, only takes 600 bytes. So now it's important to remember the compression rate can vary widely depending on the type of file. For text files, can be quite convenient, but this is just to give you an idea of why you would compress an archive. Okay, and then one last bit for this session is about just some keyboard tricks that can be quite handy in using the shell. So as you type commands, the bash shell will store the history of your commands, and you can access the history of your commands by using the up arrow and down arrow keystrokes in your keyboard. So if I now hit the up arrow once, which I've just done, you see I have just retrieved my last command. If I go back one more, I retrieve my second last, and so on, and I can execute them with enter. And I can also browse going back, go backwards in the history, so I can use the down arrow, and then going back to the last command, and then if I do it one more, I go back to the current shell, which was empty. And finally, so two more tricks. So you can skip typing the entire commands or even file names by using tab completion. What is that? So say I want to type the command hostname. So I can start and type host, and then use the tab keystroke once, twice, and the shell will suggest me possible program names. And you see there are 4. Now, if I add the n to one more character, and if I type again, So now there is just a couple of commands which start with host n, and tab will start and auto-complete it for me. And then enter to run the command. So that can be quite handy. It also works for files. ls arc tab. We will go to archive, tab, 102, 1. Tab complete. And very last trick for today, if you start and type something and then you change your mind, you don't want to type it anymore, you're lazy, we don't want to clean the prompt with the backspace, the deletion keystroke, you can use Ctrl-C to just interrupt what you are doing and go back to the empty shell, Ctrl-C, which is also handy if you want to just kill a program you're running. Again, Ctrl-C. Well, that's all for this session. So now I'm gonna hit the exit, type the exit command to exit the shell session inside Cetonix. And remember, there is the materials for this module that we're going to share with you, and it will be available on the Pawsey website with all the transcript and links. And thank you for following me in this hands-on session on Bash Shell Basics.